Welcome back, mathematicians. In this video, we are going to use the quadratic formula in order to solve quadratic equations. Let's start with the standard form of a quadratic equation, and it is ax squared plus bx plus c equals 0, where a, b, and c are real numbers, but a cannot be equal to 0. If a was equal to 0, then this would no longer be a quadratic equation, but rather a linear equation. So a has to be a non-zero real number. Now, what I'd like to focus on real quick before we move on to the formula is that all terms have been gathered on one side of the equation so that it is always equal to 0. And this has to be true whenever you're using the quadratic formula. You have to get the quadratic equation in this form where the other side of the equation is equal to 0. Well, what is the quadratic formula? It is x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And so some of you might be studying or learned about this thing called the discriminant, and the discriminant is this expression right here that is under the radical. And that discriminant, depending on the value of the discriminant, will tell you whether this equation has two real solutions, one real solution that is repeated, or possibly no real solution. Now let's take a look at an example where we have a quadratic equation and we need to solve using the quadratic formula. We are going to start by simplifying the left side and moving everything over to one side so that way we can get it equal to 0. We'll start by using the distributive property. So this will be 6p squared minus 6 is equal to 5p. And then we will subtract 5p to both sides, so that way we can get it equal to 0. On the right side, you'll notice that 5p minus 5p cancels out to give us 0. And on the left side, we don't have a like term with 5p, so this will become 6p squared minus 5p minus 6 is equal to 0. Now it's time to use the quadratic formula. Let's identify a, b, and c. So a is going to be equal to 6, b will be equal to negative 5, and c will be equal to negative 6. So let's go ahead and substitute those values into the quadratic formula. We start by saying p equals, which normally it would be x equals, but you'll notice that the variable in our equation is not x, it's p, so we must use p in this formula instead of x, equals the opposite of b, which would be the opposite of negative 5, that would become positive 5, plus or minus the square root of b squared, so that's negative 5 quantity squared. Very important that you use parentheses when doing substitution. So we're substituting values for those letters. So let's include parentheses. Minus 4 times a, which is 6, times c, which is negative 6, all over 2 times a, and a is 6. Now it's a matter of order of operations to simplify. So let's start with the expression under the radical. So we have p is equal to 5 plus or minus the square root of, now negative 5 squared, that's negative 5 times negative 5 is positive 25. Then we have negative 4 times positive 6 times negative 6. So a negative times a negative, that's going to be equal to a positive. And 4 times 6 is 144. Over, and let's go ahead and simplify the denominator. So that's 2 times 6, which is 12. So now let's keep going with the expression under the radical. That would be 5 plus or minus the square root of 25 plus 144, which is 169, all over 12. The square root of 169 is 13, so now we have p is equal to 5 plus or minus 13 over 12. We're really done with the simplifying process. We now are ready to split this up into two expressions because we have this plus or minus. So we'll have p is equal to 5 plus 13 over 12, and we'll simplify that expression. And we also have p is equal to 5 minus 13 over 12. 5 plus 13 is 18 over 12, which we must reduce, and so that would become 3/2. And then 5 minus 13 is going to be negative 8, so p is equal to negative 8 over 12, and reduce that and you get negative 2/3. And your final answer is P is equal to 3/2 and -2/3. All right, guys, good luck.